All right, so now for part 2 of systems of equations, we talked about graphing, solving a system with graphing, solving a system through substitution, and now we're going to solve using elimination. And so elimination, when you've eliminated something, it's disappeared. Okay? So that's what we're going to work on today. When we want to use the elimination method, it's best to change everything into standard form. So that's where we have our x's plus our y's equals a constant number. Okay? The coefficients are those numbers that come before the x and y. And what's going to happen is we're going to add these up. So we're going to line them up and add them up, and I'll show you what that means. So if I had, let's go back to our first problem we had. If I had the y plus 2x is equal to 7, and 3y plus 5x is equal to 15. Okay? So here I don't necessarily have this in that standard form, the ax plus by equals c. So I could change that easily, and that would just be 2x plus y equals 7. And if I was to change this other one, it would be 5x plus 3y equals 15. All right? So you can see how very nicely these are lined up. And what I'm going to be doing is just simple addition. However, my goal is to have something be eliminated. So looking at the coefficients, I have a 2 and a 5, and a 1 and a 3. And I need to look to see, well, what adds to give me 0? Because 0 times something is 0, and that's where this would be eliminated. So I could do this two ways. I think the way I'm going to pick, though, is if I were to have a negative 3 right here, then I would have negative 3y plus 3y would give me 0y. And 0y is just 0. In order for this value here to be negative 3, I would have to multiply everything by negative 3. All right? So that's what this step 3 is if it doesn't exist, multiply one or both of the equations so that the variables will drop out because the coefficient is an opposite number. So again, negative 3 and positive 3. When I go ahead and I multiply by negative 3, everything changes. And instead of 2x, I now have 6x. Instead of positive y, I have negative 6x because I'm multiplying by negative 3. Instead of a positive y, I'm going to have this minus or negative 3y. And then instead of equaling 7, I've got to equal 21. So remember, in order for this equation to stay true, whatever I do to one side, I have to do the other. So when I multiply all of these parts by negative 3, I also have to multiply this by negative 3. Now I'm going to bring my second equation down. 5x plus 3y equals 15. Oops, negative 21. Now when I add these, I'm looking at my coefficients, and I have a negative 6 plus 5 gives me negative x. Negative 3y, positive 3y gives me a 0y, which is just 0. Negative 21 plus 15 gives me negative 6. All right? You can simplify this a little bit further. Negative x is equal to negative 6. Divide by that negative 1. So my variable is positive, so x is going to be equal to 6. Now I can take this and do exactly like my second step for the substitution, and I'm just going to substitute this back up into my original problem. 2 times 6 plus y equals 7. 12 plus y equals 7. Subtract 12 from both sides, and y equals -5. All right. I could do this the same way. It doesn't matter if I choose to make the y disappear or the x disappear. So let's try it with our x disappearing. So if we start over, 2x plus y equals 7, 5x plus 3y equals 15. So remember, my goal is for the coefficient to be the same, but opposites. So if I wanted to have the 2 and the 5 be the same but opposite, I need to think about the factors of each of these. And what would my greatest common factor be? And I would choose 10. So in order to make this 10x, I would need to multiply everything by 5. And in order for this to be the opposite of 10, it would need to be -10. I would need to multiply everything in here by -2. And if I multiplied the 5 by -2, I would get -10. So let's do that. Positive 5 times 2x is 10x. Positive 5 times y is 5y. Positive 5 times 7 is 35. All right. Now, let's slide this up a little bit. We take our second equation. Remember, we're multiplying by -2, so we get that opposite constant here, or I'm sorry, opposite coefficient, so that my x's will be eliminated. So -2 times 5 is a -10x. -2 times 3 is -6, and we've got our y. -2 times 15 is going to be -30. And again, everything is lined up very nicely. And adding these together, -10x plus 10x is 0x. 5y minus 6y is a -y. 35 minus 30 is a +5. -y equals 5. Well, I can't have a negative variable, so I need to divide by -1. And y is equal to -5. Again, I want to prove this correct, so I'm going to take this and I'm going to substitute this in for my original equation, one of them. 2x plus -5 equals 7. Add 5 to both sides. 2x is equal to 12. Isolate my variable by dividing by 2. And x is equal to 6. Now that I have this value of 6, -5, I want to double check it into both of my original equations, just like we did before. So 2 times 6 plus -5, does that equal 7? Why, yes, it does. 5 times 6 plus 3 times -5, does that equal 15? And yes, it does. Okay? So here are our steps again. Here's how it is with that first solution. So let's do one more practice one with our A and our B, and you guys can do this one with me. So again, if I have 2x minus 4y equals 13. 4x plus 5, or minus 5y, equals 8. Go ahead and push pause and find your elimination. All right, so you have your two equations here, and right now you are working on setting up a solution for elimination, using elimination. So you're going to have to manipulate one of these two equations so that when we go to add them, the coefficients turn to 0 for one of these variables. So you can do that easily by multiplying the first equation in red by -2. And when you do that, you should then have two equations that when lined up and added together, the x's fall away and you're left with y equals something. So go ahead and do that yourself right now. We'll push pause and then we'll come back and finish it up. All right. Hopefully you've gone ahead and multiplied this first one by a -2, resulting in -4x plus 8y, because -2 times -4 is a +8, equals -26. And our second equation did not change at all, so we still have this 4x minus 5y is equal to 8. And so when we add these then together, do you like how red and blue make purple? When we add these together, -4 and a +4 drop away, and we have a +8, -5, so we get 3y is equal to -18, because -26 plus 8 is a -18. Isolating our variable, we're going to divide by 3, and y would then be equal to -6. Now, press pause and find your x value. So hopefully, you've come back and realized that once you have your solution of y is 6, you can substitute it into either equation. And when we do that, 2 times our x minus 4 times our y of -6 equals 13. When I do this, I've got 2x plus 24 equals 13. Subtract 24. And I get 2x is equal to -11. To isolate my variable, I need to divide by 2. And I get x is equal to -11/2. Okay? Hopefully you got that as well, and you could have done it by substituting into the other equation as well, which is up here in yellow. All right. So here's a second example where we have to change both equations in order to make that work. So remember when I said earlier you could take the 4 and 5 and make those 20 so that they could be eliminated? We're going to have to do something similar where we have to manipulate both A and B. All right, so I'm going to get a new sheet here for our second problem. And our first equation is going to be -9x plus 6y is equal to 0. And our second equation is going to be -12x plus 8y equals 0. So here I need, when I'm adding these, I need opposite coefficients. And so I've got a -9 and -12, and I've got a +6 and +8. So I need to change both of these because there's nothing that I can multiply 9 by to get a -12. That's a whole number. And there's nothing that I can multiply 6 by to get this 8. And so you could choose which way you want to do this. But here, if we multiplied by -4 and a 3, our x's would then become the 36, which we'd have a positive 36 and a negative 36, and that would add to give us 0x, which would eliminate the x, okay? So let's go ahead and do that. Let's multiply all of this by -4 and all of this by a positive 3. All right, go ahead, press pause while you do that multiplication, and then we'll meet back up again. All right, so you've finished this out, and hopefully what you've gotten is a positive 36x minus 24y equals 0, and a negative 36x plus 32y equals 0. And now when we do this, again, we've got these columns that'll add up really nicely. Positive 36 and negative 36 is a 0x. A negative 24x and positive 24x sorry, 3 times 8 is 24. Is 0y. So we just had our x's and our y's cancel and we got 0. This means that we get 0 equals 0, and this is in fact true. So what this tells us is that all solutions are possible. So every single point is always going to match up. I could put a 1 in, or a 2 or a 3 for x, and I could do the same for y, and they're always going to be true. So all solutions are going to be true for this one. There's infinite many solutions. If you were to do this and you got something that didn't equal, then you know that there are no solutions, and they would then be parallel answers. All right. When we have 3 equations, you can still do it the same way. You're not going to have to do this through for your work sample though, but it could be done, and then we can start involving matrices, which you'll come to later. So let's do some practice problems together for this so that you can do a couple on your own and make sure that you can get these correct. Okay?